Okay, so I'll be speaking in English. I guess there are some foreigners here, probably. Um, I'll be talking about the Jupyter Notebook, which is, let's say, I would probably first start with IPython, which enables people to make kind of notebooks, which means that they can write about things and also execute code in them. And the Jupyter Notebook is kind of the new way of doing that. It's an app that you can run locally. It's actually a web app, and we're gonna launch it now. Yeah, so I'm gonna go into a directory in which I have something prepared. I think it's Meetup, yeah. Okay, so in here I have something, okay. I have some a text document, some URLs, and some random file. And here I'll use this command to launch Jupyter Notebook. And we'll have to wait for a few seconds for it to appear up in the browser. Yeah, I should have prepared the joke for this, but I didn't. So let's wait just a few more seconds. Here it is. Okay, cool. So it basically lists all the files that we have in our directory. So this is Python Meetup number 3, but we're going to be using Python 2, which is the default version here. But you can also add Python 3 without any problem. So I'm going to go just a little bit back now. I'm going to go to the standard command prompt in Windows, and I'm just gonna launch the interactive Python shell. Yeah, it's probably familiar to all of you. And let's do 2 + 2 and we get 4. Okay, the very stupid part about the CMD is of course the design, and it lacks a few things. Okay, some people of course love it. Then you can go to, let's say, to a commander, which looks a little bit more pretty, but again, it's a good old terminal window, and Jupyter kind of extends all of that. We can also do like 2 + 2. We press Shift-Enter and we get an execution. But the good part about this is, let's say, if we make a variable called var, okay, we can now just add v and let's say tab, and then we get auto completion. So that's something that we don't get in the standard command prompt terminal. And now I'll do a few more things. Today, the following presenters will talk about pandas. I'll just make a slight introduction. So I'm gonna import panda numpy as MP. This is like standard. Import pandas as PD. Okay. I'll do the imports, and now this is a cell. These are called cells, and I can do whatever I want with them. This one with a star, okay, it's now 4. When it has a star, that means it's not yet executed. When I'm done with all of this, I get a file, and I can return to this file. This is something also that couldn't be done with the terminal. I can now, let's say I want to delete. If I had like 20 lines of code, I could just cut them. Okay, that's maybe sometimes not so useful. It can probably create problems. Now when I have PD imported, I'll just say PD read CSV. I have some small random file. I'll say okay. It's data.csv. Okay, and I'll assign this to a variable. Okay, and I'll say, well, okay, yeah, this will probably happen a few times. Okay, well, I get an error. Cool. This is because just a second. Does not exist. Okay, cool. It should great. I deleted the file. Cool. I think I have it somewhere here. Okay. It's not here.
There it is.
Here it is. Cool. Okay. I'll have to just. It's GP. Just a second. Sorry. Okay. Okay, now it's gonna work. Okay. So this is also a beauty of Jupyter, because now I get a spreadsheet like, okay, this is okay. This is part of Panda's beauty. This is something that these two guys are going to be talking about. But also you can execute code and get it pretty. Something that is also cool about these Jupyter notebooks is that you can, let's say, Python, okay, from IPython display import image. Okay, now I'm gonna add a URL to some image. Okay, I saved the URL. So now we're gonna get an image, but I guess that something's wrong with the internet connection. Yeah. Yeah. Okay, I got the URL, but I didn't think about the internet. Okay, it's limited. Please go offline. Okay. Okay. All right.
You can open any URL.
Okay.
In your browser, open any URL and just sign in with it. You can open it.
Okay, here it is.
Do a search.
It's okay. But here it is. Here it is. So now we have an image inside of our notebook. We can also add videos, which works similarly. We can import IPython display import. Now the cool thing is that we can import different types of. So we can use YouTube videos, and we can now, let's say, video. We're gonna load some video. Okay. The video that I'm gonna load is also about Belgrade, but it works like this. We just need to copy this part of the URL. Okay. I'm gonna stringify. Okay. Okay. Yeah, of course. Now I'll have to call this one. Here it is. We have a video about Belgrade in our notebook. So this is also something cool about these notebooks. You will see the application, the biggest application of these notebooks is not adding images and videos. We'll probably It is scientists use notebooks because they can write about certain scientific issues and write formulas and stuff, and then they can do some code and execute it. So data scientists use it probably the most because they usually want to explain what's happening with their code, and especially when they are exploring data, they can use the nice interface for that. Now, of course, all this can be, the file type. The extension is IPython notebook. How can we make a normal Python file out of this? So we just need to go to the documents, GitHub, what's the Meetup, okay, and we need to use the IPython nb convert. And tell it to convert it to the format we need. In this case, we need the Python format, and we're just gonna say, I did not name this particular file, so I want to name it demo. Okay. Now I'm gonna go here, say demo. Okay. And now it's gonna make a classic Python file. Here it is. We have a demo file. Let's open it with Sublime. Yeah, so we get all that we made in a normal Python file. The important thing that I skipped is that here we have an option to use code, to use Markdown. This is MB convert, so this is to prepare it for conversion to Python. And when we use Markdown, well, you're probably familiar with Markdown. If you want a title, say hashtag title. You can add images, you can add links, you can add lists. And so on. So it can look prettier than this, of course. Yeah, it's like this. Okay. So that's the part where you write about the code that you're gonna further on execute. Yeah. Another thing is the NB viewer. So this is something that is this is something that is generally used. It's not this. Okay. Here it is. So this is something that people generally use to share their notebooks. So let's take a look at this one. This is a Ruby notebook, but it's generally it could be applied for many languages, but mostly it is used for Python. And another useful thing is called LaTeX that can be used for writing mathematical formulas, functions, and stuff. And that's all that I have to say today. And thank you for listening.
Hey guys, we have questions and answers. The Jokic has the microphone.
Yeah.
So whoever has a question.
Questions? Anyone?
I have a question. What does IPython mean? What is it?
Well, IPython is also a library that enables you to actually make all of these things that I showed. So IPython notebooks were and are like this, but Jupyter is like a newer version. Yeah, so that's pretty much it.
Everything is basically just ran in IPython. Jupyter is just like
yeah, it's actually Still running, but I got my HDMI out. It's okay. It's still running. I didn't turn off the local server, so we'll need to tell it source HDMI.
Is IPython the one who's hosting the web service, or is something, or is
Yeah. So currently we have this notebook app, which is still running. I did close the windows. No, I didn't. But I can close the windows, and it still will be running until I tell it to stop, of course. And
is that IPython or is that Jupyter?
Jupyter.
Jupyter.
Yeah. So that's it.
Anyone else?
More questions?
No,
IPython means interactive Python.
Yeah.
It was originally UPython or Jupyter, whatever. It's a rebranding on IPython.
Yeah.
And it was also supported few more languages.
Right.
That's it. IPython supports only Python.
So the Jupyter supports more languages.
Right.
Yeah. Like R,
Julia and someone
Really?
Yeah.
for this.
That's insane.
And Jupyter is diverse from IPython in some way. It is a generalization of IPython. What way? It was restructured. Now the kernel is new. This is Jupyter kernel. And IPython is just front end. IPython is just front end. So now in kernel, when you try Jupyter with IPython, you have IPython front end and all his benefits.
The other way around.
Yes, and you are calling Python kernel. If you want some other kernel, you have in right top corner, you can call another kernel. You know.
So Ruby.
Yes, Ruby, Julia, and 40 others.
Wow. That's insane.
So that's it.
Okay. Anyone else? All right, cool. Thanks for that. Now we have like a few-minute break, and Zarko is gonna give us a little heads up on how NumPy works and how you can easily implement it to do whatever you want. All right, Zarko, you want to sit down?
Je.
Okay.
Samo bi onda iskoristio pre nego što počnemo. Ja ću pričati na srpskom. Ja sam pustio. Htio bih da pitam koliko ovdje ima ljudi koji su data analisti ili data scientisti ili... A koliko koristi Pande za to? Dobro. A ili ima neko da radi machine learning u Pythonu?
Možda mu lupiš neki duplikat to, sad ćemo, ne znam, to Windows ili Linux. Ako je Windows, onda...
Ne vidi, on ne vidi.
This is standard problems. Good. Extended.
Ne znam gdje beše. Sad kliknuo sam. Ja sam počeo.
Jesi na polju si.
Malo je sporo, ali sad će. Evo ga. To. Ovdje, no?
Da, trebaš displays, mislim da je displays. Kliknuo mirror displays.
Displays, hvala.
Why is this so already? Ja i to rezolucija. Eto.
Da počnemo, a? E pa ovako, samo par reči. Ja sam Zarko Vulikic i radim u kompaniji Telesign kao fraud research engineer, što je neka vrsta data analista, i pokušavam da pande uvedem u naš regularni proces rada, ali to je još uvijek u početku. Sada bih hteo, ima puno stvari koje sam hteo da pričam i to, pa nećemo moći da zadržimo na nekim detaljima, ali ja ću posle na GitHubu okačiti ove notebooke koje ću koristiti sa nekim dodatnim primjerima. Neću preći sve danas jer nemamo vremena, a ima toliko stvari da se priča o pandama i šta sve može. Tako da, ako ima nešto nejasno da je baš važno da se rastumači, može da me prekinete, ali u principu je bolje da me pustite do kraja, pa ćemo na kraju jer nećemo se udubljivati sad u svaki deo sintakse, samo mi je važno da konceptualno pređemo kako to izgleda, čisto da ljudi se zainteresuju i da počnu možda da koriste pande. I naravno nezaobilazni deo je Jupyter Notebook u kome ćemo sve raditi i to je neki standardni deo kada se koriste pande. Obično se misli u kombinaciji sa Jupyter Notebookom. Ja sam bio pripremio dva neka data seta. Sad smo vidjeli kako funkcionišu ove ćelije i tako dalje. Izvršit ću ovog, sad bi ukucao, zamislite da sam ovo brzo ukucao, koristim poslednju verziju Pandi 0.18. I pripremio sam bio neki data set sa neki Honda Accord polovna vozila koja su bila na nekom marketu i za njihove cene, pređena kilometraža i tako dalje, ali to data setovi i notebooksi će biti posle na GitHubu, tako da ne bih sad na ovo trošio vreme, to je osnovno pivotiranje i crtanje nekih osnovnih, nego i prešao na ono što je zanimljivije, a to je Baby Names dataset. Baby Names dataset je čuven kod analitičara i to je imena rođena u Americi, imena dece, beba. Učitat ćemo ovako pomoću read CSV, kao malo pre i Stefan što je pokazao, učitat ćemo sva imena i dobili smo data frame koji je osnovna struktura pande u pandama i vidimo da dataset sastoji od imena, pola, koliko je osoba sa tim imenom rođeno i koje godine. Znači vidimo da je Mary 1880. rođeno 7000 i nešto beba, ženskog pola. Znači ovaj dataset, ovo je sad sve učitano u memoriju, pande učitavaju sve u memoriju, imamo nekih skoro 2 miliona redova trenutno u memoriji. Sada možemo, na primjer, prva stvar koju smo mogli da vidimo je da li je rođeno više muških ili ženskih beba i u totalu za sve ove godine. Tu ima podaci od 1980. do 2014. I vidimo da je približno isto. Ako slučajno želimo da to predstavimo grafički, ako nam je lakše, možemo nešto ovako da uradimo, samo dodamo plot bar i imamo skitirano to, znači pande ispod pozivaju matplotlib biblioteke za crtanje. Ono što bismo mogli da podelimo, napravimo, da kažem, pivot tabelu, znači broj rođenih beba po godinama i polu i to suma rođenih i tako, na primjer, vidimo da je, znači sad je ovo head, funkcija head vraća prvih nekoliko redova, da ne bismo ceo set sad gledali, ali vidimo recimo da je 1880. rođeno ovoliko ženskih i ovoliko muških beba. Dalje može da nas zanima, da to skiciramo malo, da imamo šta se dešava. I samo u ovoliko kratkom kodu mi možemo da dobijemo ovaj crtež i vidimo već prvu zanimljivu stvar, a to je da u nekom trenutku, ovde nešto oko 1940. je počelo da se rađa više muških, evo ima i legenda, možemo malo da rasteretimo ovo. Znači, muške bebe su, male su zelene. Znači, posle 1940. počelo je da se rađa više muških beba nego ženskih, a pre toga je bilo više ženskih nego muških, što je to zanimljivo kako u par koraka samo možemo da skiciramo ovako neku stvar koja možda nije očigledna. Takođe, kada koristimo matplotlib u notebook režimu, imamo ovaj mali toolbox i možemo da zoomiramo. Hteo sam da zoomiramo ovde početak, gde isto imamo jedan switch gde je bilo malo više muških nego ženskih i posle su vam. Možemo kad god hoćemo, možemo da se vratimo na originalnu sliku. Možemo lako da skiciramo ovu razliku između muških, znači ovih male i female, razlika gde možemo takođe da uočimo da ih je ovde bilo znači više muškaraca, pa je ovde bilo više žena i ovde konačno ponovo više muškaraca. Ne znamo zašto, ali grafik tako pokazuje. Ovde sada, ovo neću sad proći, znači ovde kako selektujemo range, ali to ću okačiti, nadam se do sutra ujutru, na GitHub, onaj Zarko V. Zarko, pa će ceo ovaj tekst biti, sad da samo suštinu pređemo. Ovo ću tako preskočiti. Sad, znači u pandama je vrlo lako da napravimo ovako neku funkciju koja vraća, na primer, top 3 imena. I onda možemo da primenimo apply. Znači sad, to je duga priča, postoje apply, map, transform i tako imamo nekoliko kombinacija koje daju veliku moć pandama. I primenjujući ovu funkciju smo dobili za svaku od ovih godina top 3 imena. Naprimer, John je bio 1881. sa ovoliko rođenih, William, James i tako dalje, slično i sledeće godine. I mi sad imamo rankirano 1, 2 i 3 svake godine. To se naravno menjalo. Do 2014. Možemo, u stvari idemo postupno sad, da ne bude znači kada bismo ovako rekli, to bi bio group by objekat kao u SQL-u grupisanje, a ovo bi bilo znači group by i group by year and ranking, kolika je suma rođenih. Znači sad, nezavisno od imena, onaj koji je bio prvi 1880. ima ovoliko rođenih, ovoliko i ovoliko. I to možemo, ovaj unstack, koji će se često pojavljivati u ovim mojim notebookima, je zapravo samo da ga pivotira gore u kolonu ovaj ranking i mi imamo, znači kad uradimo unstack, ovako nešto dobijemo, znači da ovaj ranking ide u kolone, da bismo sad mogli jednostavnim plot, da na istom grafiku skiciramo sve kolone jedne pored drugih. I mi vidimo što se tiče muškaraca, kakva je situacija bila, da je tu oko 1950. do 60. bio neki pik, da kažem, sa popularnim imenima i ta 3 su bila približno ista, a posle kako je vreme posle toga i pre toga nije bilo toliko izrazitih, da kažem, favorit imena, nego nekako bilo sve ujednačenije. Ljudi su dobijali razna imena, nisu se grupisali oko... Ako radimo slično za žene, znači dobijemo ovakav sličan dataset, Mary, Anna, Emma. Znači, bukvalno uradim istu stvar i vidimo, eto, situacija da je malo druga, da žene su imale znači to ime koje je bilo prvo, koje god da je bilo, to se menjalo tokom godina, ali uvek je bilo to jedno ime dominantnije nego druga imena, bar svake te godine. Znači ovo nije isto, recimo ovaj pik recimo iz 47. Ovde kad se nadvijem, ovde se vidi koordinate u ćošku ovde, kada se nadvijem nad grafik, znači ovo je negde bilo 1947. I ako pogledamo dole ovo je bilo kao neki select. Hoću sva imena gde je pol bio female i godina 1947. Da sortiram po, i vidimo da je Linda bila te godine, znači ovde je Linda bila prva, a recimo ako pogledamo ovaj pik ovde je 1920, ako pogledamo ko je bio, vidjet ćemo da je to bila Mary. Ali ovde smo, znači ako bismo hteli da sad to možemo zamislimo apstraktno o nekom našem drugom datasetu, znači ko je bio prvi, kogod da je bio, možemo lako da skiciramo na ovako u samo par koraka. Naravno, za razliku od Excela, pande zahtevaju malo da se uloži vremena u učenje, ali posle mislim da je stvarno super. Jedino, sad kad smo već tu kod mana, ja bih spomenuo recimo da u pandama nisam još našao način da lako uradim non-equi join, pošto naravno pande mogu da joinuju dve data frame-a kao dve tabele u SQL-u, ne postoji lak način neki da se uradi nešto što nije jednako, ali evo sad ćemo raditi neki join koji jeste jednako. Bilo mi je zanimljivo recimo da vidimo neka imena koja su bila i muška i ženska, da vidimo kako su se ona ponašala, pa sam tako kreirao, znači postoji ovaj query metod gde možemo na ovaj način ili ovako u uglasnim zagradama. Ovo je jedan data frame su muška, jedan data frame su ženska imena. Ovaj merge je kao join u SQL-u po imenu i godini. I sad se ja tu uočio ovako je bilo. I sad mi vidimo u jednom data frame-u joinovano. John je kao muško se rodilo 1889.655 beba, dok je 46 beba sa imenom John bilo su devojčice. I tu mi je bio Willy, zanimljiv kao neko koji je imao Willy u početku, sad ćemo vidimo kako je bilo ime Willy u početku. Tu je negde, znači približno su bili, ali sad to brojevi, bolje vidimo na grafiku, lakše ćemo da skapiramo šta se tu dešava. Ista ova stvar, samo sa plotom. Znači evo, do 1920. i neke, čak je Willy bilo kao žensko ime dosta zastupljeno. Možemo čak lako da skiciramo i odnos broj muških beba sa imenom Willy podeljeno sa brojem ženskih beba sa imenom Willy. Ovako je išao taj odnos. Znači u početku ovde je bilo skoro 1:2, znači bilo je malo više muškaraca Vilija nego žena, međutim kako vreme prolazilo sad ima 80 puta više Vilija muškaraca. Hteo sam da pokažem i samo rolling window, kada bismo hteli average Vilija, broj muškaraca Vilija kroz žena, average na 5 i na 10 godina, to bismo mogli pomoću ove funkcije rolling. Ovo je, kažem, za Pandas 18, to je poslednja verzija, u prethodnim je bilo malo drugačije, ali ovo je sad ovako. I evo vidimo, znači možemo i rolling window, možemo min, možemo uraditi samo, možemo bilo koju funkciju primeniti na window. I poslednja stvar koja je bila zanimljiva, a to je interact widget, koji je zapravo deo Jupitera, odnosno IPythona. Definisao sam, recimo, ovo je sad nebitno, bez veze sam uzeo kao funkciju koja za zadatu godinu po kvartilima prebroji koliko je bilo imena. Ovo je sad samo za muškarce, uzeo sam DFM, iskoristio sam ovde ovaj mali prljavi hack, global DFM, da mi gleda onaj DFM koji sam definisao gore, jer ovo je na brzinu. I podeli sa ukupnim brojem, znači u procentima u svakom kvartilu koliko je bilo. I sada ono što mogu, ovo može znači za bilo što drugo da se primeni. Mogu da dobijem ovaj slider. Sad mi recimo ovo je prvi kvartil, ovo je drugi, ovo je treći, ovo je četvrti. Ovakav je neki bio odnos. Ovi u zbiru treba da daju 1, pošto sam podelio sa ukupnim brojem imena. Ali mogu da im recimo kako je to bilo 1912. Ovakav odnos. ili 1991. ovakav. Hoće da kažem, možete napraviti zanimljive ovaj interact widget koji može da se skiciraju neke različite stvari u zavisnosti od parametra. I naravno, kada delim sa kolegama koji ne koriste IPython, odnosno Jupyter, mogu da sačuvam ovo kao HTML i onda će oni videti ovo, sve ove slike i to u HTML-u, mogu da scrolluju gore dole, mogu da vide slike, datasetove i kako je išao tok misli, kako je to bilo, eto. Toliko je, ima mnogo da se priča, ovo je kao nešto najkraće, izbacio sam dosta stvari, ali okačit ću sve ovo, znači, na GitHub Zarko V. Zarko, nadam se do sutra ujutru, zavisi kako noćas bude išlo.
Any questions?
Ja imam jedno pitanje prosto iz malo više uglova, ali probat ćemo da to sve sažmemo u što je manje moguće reči. Vrlo je dobra prezentacija, mislim da je bila efektivna i ono što bi bilo možda u nekoj budućnosti moguće integrisati jeste neki primjeri u kojima Python supstituiše mogućnosti konvencionalnih statističkih paketa, pošto za produkciju ovih vizualizacija, makar iz mog iskustva, ja se najviše bavim integracijom statističkih paketa i Pythona. Statistički paketi imaju veliku prednost kad je reč o konkretno ovim oblicima vizualizacije i Python mnogo bolje funkcioniše na planu automatizacije, dinamičkog kreiranja, raznih funkcija koje kasnije omogućavaju neki nivo funkcionalnosti koje sam statistički paket nema. Ono što mene zanima, da li ovaj paket matplotlib omogućava ponderisanje podataka, da li možete da prikazujete ponderisane podatke, da li možete da koristite UTF-8 ili 16, svejedno, jer imam problema sa tim srpskim slovima i svim ostalim. I to bi bile neke dve osnovne teme i da li u budućnosti možemo da očekujemo ggplot da se malo više eksploatiše kroz Python, pošto sam vidio da postoji ta biblioteka za Python. Eto, to bi bilo neke observacije. Znači, ponderisanje UTF-8, to mi je baš bitno, R, na primjer, to jako loše radi.
UTF-8 trebalo bi da je standardno, to više nije do Pandi i to trebalo bi standardno da podržava Python, tako da pogotovo trojka to bi trebalo da radi. A za ponderisanje, to sad ne zavisi, Matplotlib je samo biblioteka za crtanje. Sad, koje je tačno ponderisanje, ne znam sad na što misliš, ali nema veze, uglavnom sve, mislim da sve može da se napravi, ima stats, da, to sam hteo, da, samo sekund, od literature i to postoji ovde pandas ekosistem, ako ukucate na Google pa se tu vidi, evo ga, znači ima ggplot, znači postoje neke, tu su neke dodatne te biblioteke ili znači ako budete kucali pandas ekosistem, možete dobijete ove neke stats models, pretpostavljam da ćeš tu možda naći nešto, i evo ga ggplot i tako dalje, sad nisam ulazio u te neke. Onda standardno je, kad smo se već dotakli, dokumentacija pandas documentation i tu postoji 10 minutes to pandas koji nije loš kao neko početno štivo. Naravno, tu je knjiga Vesa Mekinija koja je inicijalno napisao, Python for Data Analysis. Ona je jako dobra, tako da ko može da je nabavi, ona je vrlo, vrlo dobra. I na GitHubu su data setovi iz te knjige Vesa Mekinija, tako da ko hoće može da se igra sa nekim konkretnim podacima. A znači za ovo ponderisanje ne znam, ali evo u ovom ekosistemu ako nešto piše, taj ggplot isto i nisam napisao taj matplotlib i to.
Okay, anyone else? More questions? Okay, thank you, Zarko.
Wow, hvala Žarko. Sada ćemo da vidimo šta možemo da uradimo s tim podacima i u šta da ih stavljamo. Miloš o Sparku, ali nakon 2 minuta setup. And we're gonna do it in English.
Okay, I believe this is okay. Okay, so I have a presentation for you today. So I will talk about PySpark because I'm using PySpark on a daily basis to do some data processing because I'm working at a company called ThinkSolver. I am data engineer there and co-founder. And we are using PySpark, Python tools, and some other big data tools to tackle the problem of handling massive volumes of data. So before I continue, is there anybody here who is working with big data problems or big data scale? Okay, cool. Has anybody had a chance to try Spark or PySpark or something similar? Okay, cool. And the last question, do you know what is Spark? Okay, cool. But I will, I will have to lead you just through basic concepts of Spark. So Apache Spark represents a very fast general processing engine. It is developed at Berkeley University. And it's really amazing when it comes to handling massive volumes of data because Hadoop had really big problems when it comes to data analytics, data processing, because Hadoop MapReduce process is really slow, because if you have iterative processes, in each iteration the data is stored to HDFS, to file system, so in each iteration you need to read the data again from the file system. Of course you can handle that if you write your own MapReduce programs, but that's really hard. So Spark is really good solution for these kind of problems. So what Spark actually does, it is that improves efficiency through in-memory computing primitives and general computation graphs. And people at IBM who is really working hard to develop Spark, they usually call Spark a dumb engine because it has a lot of capabilities for data processing, but it's up to programmer to handle everything and to show this engine how to tackle the data problems. And what is great thing is that Spark offers really rich APIs so we can explore all of our data. And actually API for Python was recently introduced, actually recently became stable so we can use it in production and build all our application for data processing in Python. And the important thing to know is that Spark is written in Scala and it's working on JVM. And then if it comes to using Python for working with Spark, some functionalities are still implemented on JVM. Spark basically has a lot of components, but we can identify the 5 main components. The most important one is Spark Core. It's where all the core libraries of Spark reside. So they're handling all the issues with the memory, handling all the data jobs and tasks we are handling. And also it gives us a chance to explore our data. And there is Spark SQL, which actually allows us to have SQL queries on top of big data and large data volumes. There is Spark Streaming, which allows us to have a kind of near real-time data processing, streaming analytics. MLlib, which is a really handy tool for machine learning tasks, and it's really important here integration with Python, because for example if you are doing some, I don't know, k-means clustering and you are using PySpark, all the core computations will be calculated using NumPy. And there is graphics, but it's really it's a tool that really needs to be worked on because there is only API in Scala and it's not so well developed. And that's another important thing to say is that Spark basically does all the computations in memory. Actually, does not by default, but there is a way for developer to show Spark how to store all the data in memory, so we don't have to read it from the disk in each iteration. the core concept of Apache Spark is a resilient distributed data set, and it represents memory abstraction, memory unit abstraction, which resides in memory and stores some kind of data. And RDD is an immutable partition set of objects. And what is great here is that when we are using PySpark, actually Python API for Spark, we have dynamically typed capabilities, so we can store objects of all kinds of types into RDDs, which is not possible in some other APIs. RDDs are lazy evaluated, fault tolerant, which means if we have lost some, I don't know, some RDDs, there is some problem with some machine that is calculating something, those RDDs can be easily calculated because there is a lineage graph where all the data, all the information about how some RDD is derived is stored. So if we have lost some RDDs, they can be easily recalculated. And RDDs support two kinds of operations. We have transformations and actions. So basically, transformations are lazy evaluated. So if you run a transformation on top of some data, actually nothing will happen. We cannot see that result. Just the field in the lineage graph will be updated. So when we call some other action, that transformation will be processed. Some transformations like map, filter, group by key, and join. And we have actions that actually return some output to the user, to someone who is working. So basically, it's if we want to print out some results in our shell, or we want to, I don't know, store data on some other file system delivered somewhere else, we call an action which actually does something and calculates on top of data. And another important thing is to use cache. So by default, Spark does not work with memory, but we are using cache to store some data set in memory, so we can easily do calculations later on that. And especially when it comes to big data problems, we cannot, it doesn't make any sense to store like the whole data set in memory. So we basically do some transformations and actions, and we get some subset of the data like that is filtered or something like that, and then we cache that just partition of data, keep it in memory, and do some other calculations. And what is actually PySpark? So PySpark is a Python API for working with Spark applications. It actually exposes the Spark programming model to Python, and it sits on top of Spark and Java API, and it tries to preserve like all the core features of Python. Like the main idea of PySpark is, okay, we have some data sets here, here's the operation, and you should run this operation on all data we have. And here is an example you have to have on your slides if you're talking about Spark. So it's a simple word count example. It's kind of hello world example for Spark. So what are we actually doing? The first line, we are reading some text file from some HDFS location. So we might have there a lot of some, I don't know, text corpuses that we want to process, and we read them from file system. And then we call functions, operations on top of data. So first we take that text file that we read from the file system, and then we call flat map. It's a transformation that is run on top of RDD. And we're calling lambda functions. So Spark, actually, PySpark supports all the lambda functions as they're available in Python. And we're calling a lambda function, anonymous function, that takes each line into files we have read and splits it by white spaces. So we have like an array of all the words within some lines. Then we are doing map function again on top of that data, calling another lambda function that will take each word and transfer it to tuple of word and one, which represents the number of occurrences of that word. And then we are calling reduce by key, that is doing some kind of grouping by the word actually we're working on. And we are calculating, counting actually the number of word occurrences within a text. And what is important thing to know that until this last line, nothing actually happens. So our lineage graph will just be updated, and we cannot see any processing, nothing happening on our cluster. And when we call counts.collect, which actually prints out all the results collected from some operations, actually the application goes through all of these functions, and we finally see the result in our shell or wherever we're working in. So when it comes to PySpark implementation, it's important to know that PySpark represents only a thin layer that is built on top of Java, API, and Scala, because people who were working on Python API didn't want to change like really good things that were already implemented in Spark. It was really didn't make any sense to build a whole new engine just in Python. So all the good things that were working already, like for handling memory issues or fault tolerance and stuff, it's still there in Java running on JVM. And Python is used here only for computations. So for example, if you have, I don't know, machine learning, some machine learning algorithm, you will write your application in Python, which will actually be delivered and scheduled on top of JVM. And then the final computations will be run also in Python again, and then transferred to the application that called the program, and the results will be returned in Python objects. And the important thing that is used here to know is that they were using engineers Pickle serializer, which is a really great serializer for Python objects. So we can have easy communication from Python to JVM and otherwise. And on top of that, realize Py4j. I will talk more about it later. And it was really still very slow, so another optimization they were using is to store batches of Python objects, like in one Scala object, so it can easily be transferred from one machine to another. And whenever possible, PySpark API tries to pipeline like all the transformation that are called on top of RDDs for processing. And we can see here actually how every application in PySpark is run. So basically this is our local machine where we are writing our PySpark project. And here is a cluster of computers where we are actually doing computing, where we are computing some data and working on some analysis. So here we write our project. And when we call our project, our application, we have a Spark context in Python. So Spark context is basically an entry point for Spark applications. You cannot work without Spark context. So Spark context is initialized in Python, and underneath in JVM, we also have a Spark context built on top of Java, JVM. And these two can easily communicate, and they're using local file system for communication with some larger files and stuff. And Py4j is responsible for this communication too. So after the Spark context is initialized in JVM, this Spark context here initializes like all the other processes on worker nodes that are actually doing the computations on top of data. So we have all these Spark workers initialized on some machines we have in a cluster. And each of them runs a separate Python job, which does some computation. So if you're working with k-means clustering, this here is some computation, like measuring the distance and stuff. And after each of these processes is finished, all the data is returned to the Spark worker. And then from these Spark workers to the Spark context on JVM. And then using Pickle serialization, Py4j, return to our Spark context so we can see all the results on our local machine. And what is important thing that while implementing PySpark, it's really important to use all the core functionalities of Python, and that's the reason why it was implemented with CPython and not, for example, Jython, because Jython does not support all of the core functionalities of Python. So basically, you can use all of your native libraries from Python for doing PySpark applications, for making them. And how do we import any, I don't know, libraries? So if there are some built-in libraries, we just call import on each library and use it normally as any other Python application. And otherwise, if there are not some standard built-in libraries, especially when it comes to pandas, for example, when we need to use pandas for computations on Spark, we call some of these functions, do some of these approaches. So we can pre-install all the packages on nodes that are actually workers that are doing processing, or we can call it with these py files for running applications, so we can just type here the name of the script we want to use, or use this function sc.add_py_file, so we can add all the foreign files that we need to use within our application. And another important thing for PySpark is data frames, because before data frames were introduced in Spark, nobody recommended to using Python for production applications actually. It's really great to use it for, I don't know, testing and learning, but it is really unstable for using in production. So Spark data frames are actually just as usual data frames, so they basically consist of columns and rows. Well, I know each column represents some measurement, and we have our observations in rows. And the only difference is that Spark data frames are distributed. So they're distributed across clusters, and they are also lazy evaluated. And they're kind of similar to Pandas data frames, but important things to know when it comes to implementation is that Pandas data frames work on single machine, and there's no parallelism by default, and this doesn't apply to Spark data frames, which are distributed by default and that are using parallelism for processing. Pandas have an amazing API, while Spark data frame API is good, but not that well developed as Pandas. And Pandas data frames are mutable, so we can change their state, change their value. And that is not the situation with Spark data frames. And this is like the very famous benchmark that is used. So this is the time before the Spark data frames were introduced. And you can see here performance of aggregating 10 million integer pairs. So we can see that Python was way more slower than Scala. So really application with this probably wouldn't work in production. But after the data frames in Spark were introduced, now Python and Scala basically have no difference when it comes to performance of the application. Okay, and that is pretty much it from me. Are there any questions or?
Anyone? Mora da ima neko pitanje, ajmo ljudi.
I have a question.
Sure.
So the lambda expressions you're using in MapReduce, does it have to be lambda? Can it be a function?
Sure. Basically, you can type any function, and just let me turn to the slide where I called lambda function. So here, so we can define some other function that does some, I don't know, aggregating some rows or whatever. And instead of calling here lambda, we can just here put the name of our function, and everything will be calculated.
Yeah, but how deep can you go with that function? Can you import libraries?
Yeah, sure. Basically, you can do everything except for the machine learning. That's where the things become trickier. But there are some, I don't know, like already solved applications and problems by community, by some other companies. For example, there is a tutorial how to use sklearn within Spark. It's a bit trickier when it comes to that kind of complex applications. But for something basic, it's really pretty much easy. For some not so, I don't know, complicated libraries.
Anyone else? If no, I have a question.
Sure.
Can you give some examples where Spark is good to use in?
Compare it with Elasticsearch, please.
Yeah.
Okay, I can see that Elasticsearch is really popular. Okay, so basically where we are using PySpark is, I don't know, if we have a lot of JSON data, so we are using it to process it because we can easily read all the JSON files into Spark and query it like a normal SQL language. So that's the really handy part when it comes to application. Why are we using it? And we we're using it for near real-time calculations. For example, we have a project where we're working with some sensor data, and we have data that is coming in real time. And we need to have like some near real-time analytics, but not the real time. Like, I don't know, for that kind of projects, we will probably use something else. For example, if you're working with bank transactions, then you cannot use Spark because it's not real time exactly, but it's really great for stream analytics. And of course, for machine learning for the large data sets. Yeah, big data ETL also. For example, we have, I don't know, some not so standard sources of data. Spark is really good here for handling these kind of tasks. So I hope I answered your questions.
Anyone else? Someone? No? Okay. Thank you, Milos.
You're welcome. Thank you.
Hi. Okay. Thank you, Milos. That was a really fun presentation. That's it for today. I would just like to thank our sponsors for the beer, the Carlsberg and Toptal as well. So I hope you had fun today. After this, we're gonna go to Silicon Drinkabout, which is hosted at Miners Pub. You're gonna have to follow that big guy over there. Yeah, it's a bit far away, but yeah, we'll make it. And join our friends at the Silicon Drinkabout there.
Oh, yeah, you have beer still here, and
Yeah.
if you're interested for big data, you can follow Big Data Meetup that Milos and Zarko and Branko leading. So with data science. Okay. Thank you, everyone.
Right, thank you, everyone.